Hi everyone, welcome back to this video series on data centers, Introduction to Access Lists. At the most basic level, an access list is a list of conditions that categorize packets, and because of this can be really helpful when you need to exercise control over network traffic. An access list is actually so effective in this kind of situation. It would be your go-to tool, the tool of choice for decision making. One of the most common and easiest to understand use of access lists is filtering unwanted packets when implementing security policies. For example, you can set ACLs up to make very specific decisions for regulating traffic patterns, so they'll allow only certain hosts to access web resources on the internet while restricting others. With the right combination of access lists, network managers give themselves the power to enforce nearly any security policy they can invent. Creating an access list, ACLs, is really a lot like programming a series of if, then, else statements. If a given condition is met, then a given action is taken. If the specific condition isn't met, nothing happens and the next statement is evaluated. Access list statements are basically packet filters that packets are compared against, categorized by, and acted upon accordingly. Once the lists are built, they can be applied to either inbound or outbound traffic on any interface. Applying an access list causes the router to analyze every packet crossing that interface in the specified direction and takes the appropriate action. There are a few important rules that a packet follows when being compared with an access list. It's always compared with each line of the ACL in sequential order and progress in that way, beginning with the first line of the ACL, moving to line 2 and then line 3 and so on. Packets are compared with lines of the ACL only until a match is made. Once the packet matches that specified condition delimited on a new line of the ACL, the packet is acted upon and no further comparisons take place. There is an implicit deny at the end of each ACL, which means that if a packet doesn't match the condition on any of the lines in it, the packet will be discarded. Each of these rules has powerful implications when filtering IP packets, so keep in mind that creating effective access lists will take time and practice. There are two main types of access lists for the objectives: standard access lists. These use only the source IP address in an IP packet as the condition test. All decisions are made based on the source IP address. This means that standard access lists basically permit or deny an entire suite of protocols. They don't distinguish between any of the main types of IP traffic, such as web, telnet, UDP, and so on. Standard ACLs are old and not used any longer in production networks. Extended access lists. Extended access lists can evaluate many of the other fields in the layer 3 and layer 4 headers of an IP packet. They can evaluate source and destination IP address, the protocol field in the network layer header, that the port number at the transport layer header. This gives extended access lists the ability to make much more granular decisions when controlling traffic. Named access lists. I said there were two types of access lists, but listed three. Well, technically, there really are only two, since named access lists are either standard or extended and are not actually a separate type. I am just distinguishing them because they're created and referred to differently than standard and extended access lists, but they're functionally the same. Okay, so once you've created an access list and understand that it's not really going to do anything until you apply it, yes, they're on the router, but they're also inactive until you tell the router what to do with them. To use an access list as a packet filter, you must apply it to an interface on the router where you want the traffic filtered, and you've got to specify which direction of traffic you want the access list applied to. There's a good reason for this. You may want different controls in place for traffic leaving your enterprise destined for the internet than you want in place for traffic coming into your enterprise from the internet. So by specifying the direction of traffic, you can, and frequently you need to use different access lists for inbound and outbound traffic on a single interface. Inbound access rules. When an ACL is applied to inbound packets on an interface, those packets are processed through it before being routed to the outbound interface. Any packets that are denied won't be routed because they are discarded before the routing process is invoked. Outbound access lists. When an ACL is applied to outbound packets on an interface, packets are routed to the outbound interface and then processed through the access list before being queued. Here are some general guidelines to follow when creating and implementing access lists on a router. You can only assign one access list per interface, per protocol, and per direction, meaning you can have only one inbound access list and one outbound access list per interface. Organize your access lists so that the more specific tests are at the top. Anytime you add a new entry to the ACL, it'll be placed at the bottom of the list. So using a text editor for access list is highly recommended. You cannot simply remove one line from a numbered access list. If you try to do this, you will remove the entire list, which is why it's best to copy the ACL to a text editor before trying to edit it. The only exception is when using named access lists. Unless your access list ends with a permit IP or any command, all packets will be discarded if they do not meet any one of the list tests. This means that every list should have at least one permit statement or it will deny all traffic. Create ACLs and then apply them to an interface, because any access list applied to an interface without access list test statements present will not filter traffic. Access lists are designed to filter traffic going through the router. They will not filter traffic that has originated from the router. Place IP standard access lists as close to the destination as possible. The big reason we don't use standard ACLs in our networks is that you can't place one close to the source host or network, because you can only filter based on source address. This would mean that any and all destinations would be affected, and it's why standard access lists are typically used in today's networks. Place IP extended access lists as close to the source as possible. Since access lists can filter on very specific address and protocols, you don't want your traffic to traverse the entire network only to be denied. So placing this list as close to the source address as possible will ensure that it filters network traffic, but before unnecessarily using up precious bandwidth. Before we move on to how to configure access lists, let's discuss how ACLs can be used to mitigate the security threats discussed earlier in this chapter. Mitigating security issues with ACL. Here's a list of the many security threats you can mitigate with ACLs. IP address spoofing inbound, IP address spoofing outbound, denial of service, DOS, TCP, SYN attacks, blocking external attacks, DOS, TCP, SYN attacks using TCP, intercept, DOS, Smurf attacks, denying filtering ICMP messages, inbound, denying filtering ICMP messages, outbound, denying filtering traceroute. It's generally wise not to allow any external IP packets that contain the source address of any internal host or networks into a private network. Just don't do it. Here's a list of rules to live by when configuring ACLs from the internet to your production network to mitigate security problems. Deny any source address from your internal networks. Deny any local host address 127.0.0.0/8. Deny any reserved private address RFC 1918. Deny any addresses in the IP multicast address range 224.0.0.04/4. None of these source addresses should ever be allowed to enter your internetwork. Before we get to work on configuring some advanced access lists, I need to cover the inverse masking that can be used with ACLs with some examples to get us started. I'll start off with simple examples, and then after we understand the basics, we'll move into the NX OS access list configuration. So I'm going to do it here today for this video. If you like listening, please consider like, sharing, and subscribing. Thank you.